When we're dealing with gases, sometimes the trickiest thing to do is to figure out which equation to use, what kind of problem it is. So you need to get good at looking at the givens and deciding where to go. So I'm going to go through and look at my numbers. I have a mass. And I also know what the gas is. It's CO2. It's not a mixture. And so one thing I might think about is that all the gas laws involve moles. They don't involve grams. But since I know what the gas is, I know I can get moles if that's what I want. Okay, using the molar mass. And so then I'm asking what volume. And I have a pressure. And I have a temperature. Okay, so then I think it's not a mixture, it's pure gas. Nothing is happening to this gas. It's heating it, cooling it, compressing it, or anything like that. So that indicates that I'm probably going to use the ideal gas law. Okay, and so just to check, I have a pressure, I have a temperature, I'm looking for volume. Of course, I know R. And I already set a way that I could get moles. So I got to get this in. And then I can plug in and get my volume. Now, we know that R has units, and it makes the units picky on this. I need to make sure I use units that match R. And of course, temperature always has to be in Kelvin. So I'm going to kind of go through. It looks like our pressure is fine. Our volume will come out in liters because that's what R has. I need to know moles. So I'm going to take my mass. And like I said, here I can use the molar mass of CO2, which is 12 for carbon plus 2 times 16 for oxygen. That's 44 grams per 1 mole. So I'm dividing, and I get a really big number. There's a dot there. So sig fig wise, I only have 3, but I don't want to round that. I'm going to round it at the very end. So now I have my N in the right units. I need to have my temperature in the correct units as well. So I have 30.00 degrees C, and I need to add 273.15 to get Kelvin. Okay, and so now I have everything in the right units. I'm going to go ahead and put it into what I like to call PIV nRt, the ideal gas law. And so and then I can see my units cancel. This K cancels with that K. This mole cancels with that mole. I see I have atmospheres in the numerator on both sides, assuming there's kind of a 1 under here. I'm basically multiplying both sides by atmospheres when I cancel those. And I can see the only units that's left is liters, so that makes sense. What I'm really doing is I'm dividing both sides. I don't always show this algebra. This is pretty simple. Oops, atmospheres is gone. I'm dividing both sides by that 1. So it's kind of silly to show that step here, but anyway, I multiply this out and I get a really big number, and I'm going to round it to 3 sig figs. That makes sense that it would be a really big number because that's a big mass, and you know how gases are, they're really spread out.